Okay, everybody. Well, we had fun with the last example, so one more example of something that looks relatively complicated, but in fact actually comes out to be fairly interesting and not as bad as you might think. This says we want to take the logarithm base 3 of the quantity, logarithm base 3 of x, and the result of that should be equal to 1. So what value of x satisfies this equation? Well, this is where we need our definitions, right? We're taking a logarithm, base 3 of something, and that's equal to 1, right? So we know what happens by our definition. It is that if I have the logarithm base b of x equal to some number y, it's only because x is equal to b raised to the power y. Right? So what is our base right here? Our base is 3. So what we're going to do is we're going to take both sides right here. This was our exponentiation rule. Okay, so for our case, what this really means is that when we take this logarithm right here, base 3 raised to the first power, it means that whatever was in this parentheses in the first place right here would be equal to 3 to the first power, correct? All right, so what do we really have in here? Well, keeping this kind of diagram in mind, let's take a look at our expression. We've got the logarithm base 3 of, well, logarithm base 3 of x. But it doesn't really matter that that's logarithm base 3 of x, because now we just get logarithm base 3 of x is equal to 3 to the first. And so if we wanted to pull the trick again, we can certainly do that. Exponentiate on both sides with that base 3. And once again, we do the same trick, and we end up with x is equal to 3 to the 3. Well, we could think this is 3 times 3 to the first, but really, what is that? Well, very simply, that's x equals 27 is our solution to this equation. So as weird as it looks, an equation like this is actually relatively simple and straightforward if you know your definitions of the basic logarithms. Okay, good luck with your homework. We'll see you in class.